Hello there and welcome to lesson 22 in the series to learn programming in Scratch. In this lesson you will write a platform game where a sprite jumps on platforms to climb Table Mountain. You will also create your own blocks in this lesson. Table Mountain, the majestic landmark in Cape Town, was declared one of the 7 modern wonders of nature in November 2011. Table Mountain has a plateau of about 3 kilometers. And the mountain is visible from 200 kilometers into the open sea on a clear day. It is 1,086 meters high, and Devil's Peak lies to the east and Lion's Head to the west of the table. On the southern side is the Cape Peninsula, where the national park is located. Table Mountain's tablecloth is a cloud often covering the top of the mountain during the summer months. When the Cape southeastern wind, the notorious Cape Doctor, blows against the mountains of the peninsula, the air is forced upwards. Once it reaches the cooler upper air, the water vapor in the air forms thick white clouds. A local legend attributes this phenomenon to a smoke contest between the devil and a local pirate named Van Hinks. Visitors can travel to the crest of the Table Mountain by cable car and enjoy views across Cape Town, Table Bay, Leeuwkop and Robben Island to the north and the Atlantic Ocean to the west and the south. People can also reach the top of the mountain on foot, if they're fit enough. Many plant species are indigenous to the area. The mountain's most famous flower is the beautiful red disa, which is known as the pride of Table Mountain. Beautiful silver trees, many species of Cape fynbos, and the king protea can be seen here. Small mammals such as baboons, steenbok, rabbits, porcupines, meerkats, snakes, lizards and tortoises, and little grey skunks live on the mountain slopes. Now answer the questions on this topic in your workbook. Today you're going to code a sprite to jump from platform to platform to climb Table Mountain. You will give the sprite gravity to make the jumps more realistic. In the lesson about the Castle of Good Hope, you've used the arrows keys to move in 4 directions. However, you had to push the keys repeatedly. The key press block, however, can be used in a forever loop to give continuous movement. This light blue block from the sensing group checks whether a particular key is pressed and makes the condition block true if it is pressed down and false if the key is not pressed down. For example, this block lets the sprite move continuously while the left and right arrow keys are pressed. You will write your own block to draw a square on the stage today. To be able to draw, import the pen group like you did in the lesson about Namakwaland. This dark green block from the pen group lets the sprite leave a trail wherever it moves. And this dark green block from the pen group lifts the pen up so that the sprite does not leave a trail anymore. For example, these blocks will draw a small square with sides of 10 steps each. Like this. Now let's create a new block to draw this square. This block will contain all the code blocks to draw the square. You can then call this new block repeatedly wherever you want to draw a square. The way to create a new block is similar to creating a variable or a list. Click on My Blocks, then type in a name for the new block and click OK. Now hook the blocks that you wrote before to this heading. These blocks define the new block square. The new block is called in your program by using the name of the block. This block can only draw a square of one size, however. If you want to draw bigger squares or other polygons, you'll have to create other blocks to do so. Here is an example where your new block is called repeatedly. To make your block more versatile, you can add input values or parameters. A parameter receives data from the call statement, and this value can then be used inside your block's definition. The square block in the previous example could only draw a small square of one size. If you add a parameter x to input the required size for your block, you can draw squares of different sizes with the same block. This block, square 2, draws a square with sides of any length. Call the block in your program by using the name of the block together with a value for the input. You can use the input value by dragging the value with a mouse to the place where you want to use it. Here is an example where you call the block with different parameter values. You can even use more than one parameter. The following example creates a block to draw a polygon with any number of sides of any length. When you call this block, you will use the name of the block as well as two input values. The first input value is the length of the side, and the second, the number of the sides in the polygon. Here is an example where you call the block with different parameter values. Gravity is a force that attracts the body towards the center of the earth or towards any other physical body having mass. That is why you always come down when you jump, and you fall faster and faster when you jump from an aeroplane, for example, before you open your parachute. When a sprite jumps, it should exert a force against gravity. The two forces work together, so the actual movement will be up or down depending on which power is the strongest. When the sprite jumps, it should move slower and slower and slower until it starts falling again. It should not be possible for a sprite to go higher and higher indefinitely. Also, if the sprite touches the ground or the bottom of a platform, the sprite should stop moving. It should also not get stuck to the platforms, so you should move it away from it slightly to break loose. This example stops the sprite if it lands on a platform or bumps the bottom of a platform and breaks free from the platform. The loop executes until the sprite breaks free. When you create new blocks like this, you can let the block run faster in turbo mode so you don't even see that the sprite moves into the platform and out. Just click the box that says Run Without Screen Refresh. So let's create our platform game now. Use an appropriate background so that the monkey sprite can climb up Table Mountain. Save the program as Table Mountain. Create a sprite with platforms for the monkey to jump from platform to platform. And also create a sprite for the endpoint right on top of the mountain. The game is over as soon as the monkey touches this sprite. And then use a monkey sprite and write code for it to move with the arrow keys. Make use of gravity to make the movement realistic. The sprite must land on platforms and should not be able to move through platforms. Save all the changes to the program. Here's an example of what your program might look like. Now use the design cycle as always. Write down any questions you have about the exercise in your workbook. Discuss it with your friends, use the internet, or ask the teacher. Brainstorm some creative ideas and different options. Draw the design for the background and the position of the sprites and label the sprites in your workbook. And then write down all the algorithms. You need an algorithm for the platforms to appear and disappear. You need an algorithm for the background to change when you reach the top or when the monkey falls to the bottom. You need an algorithm for the monkey to jump with the arrow keys. And you need your own block for gravity. You will find more details in your workbook. Now write your program and check that your program meets the criteria against this rubric. And then write down a few thoughts when you reflect on this lesson. In the next lesson, you will create a maze in which you must collect 10 pieces of gold in a mine full of ghosts. You will learn how to clone a sprite so that you write code for one sprite but you use many of its clones in the program. Until then, goodbye.